All right, the next couple of units you go through in algebra are just a lot of building of tools. Okay, as you move on in mathematics, there's a lot of times a need to write things in a different way in order to understand them or set them up to do something you are pretty good at. So we're going to be working on a lot of different ways to just take things and maybe combine stuff together or manipulate them or rearrange them, just ways to write them in a different fashion that might reveal something or just give you a shortcut and make things easier. So we're going to start here with what we call adding and subtracting polynomials. Now, polynomials just means there's a lot of terms. And what we need to know is if we're adding and subtracting, it is very, very picky. That means they have to be like terms to go together. So what makes it a like term? Well, take a look at the exponent and the variable. If that combination is the same, I see it the same over here, then I can just add those together. But I don't change what it is, I just say how many of them there are. Let's pretend x squared represents a $100 bill. Well, in this case, I have 3 $100 bills, and I'm adding it to 8 $100 bills. That gives me 11 $100 bills. Notice I didn't change the x squared. It doesn't become something new. Now, I look across as I move my way through this problem. I see, okay, there's 5 x's. Let's say x represents a $10 bill. So I have 5 $10 bills, and I'm adding that to, oh, it's out of order. Look at that. I'm adding that to negative 4 $10 bills. See, I got to find that, and that tells me I have like terms. So 5 plus negative 4, so I have 5 $10 bills and negative 4 $10 bills. I end up with just positive 1 $10 bill. And now I got just the regular numbers that most people are pretty good with. Negative 7 plus 2 is going to give me negative 5. So there's my resulting polynomial. I can't put all those terms together because the variables mean something different with those different combinations. Now, if I look at subtraction, this does get a little messy. So here's what I'm going to recommend. And there's a lot of ways to approach this, but I want to remind you that when you don't see a number in front of an entire grouping or entire parenthesis, there's really a 1 there. So there's really a negative 1 here, even though we don't always treat it that way. I'm going to distribute that negative 1 to everything, and then I'm just going to do what I did here. I'm just going to add them together. So if I do that, I end up with a negative 7x squared. I end up with a positive 4x, and I end up with a positive 12. Okay? And now once I've done that, I'm just going to get rid of this stuff. I don't even want to look at it. It's just going to take me off track. If I can distribute that negative sign, now I'm just going to add like I did in the first problem. So if you make that adjustment every time you see subtraction and then a grouping symbol, this might become a lot easier. And now as we walk our way through this problem, we go, okay, 5x squared, what could that go with? Well, negative 7x squared. There's my like term. When I add them together, I get negative 2. X squared stays the same because I'm just saying how many of them I have. I'm not changing it to something new. Then I go, okay, how about, so work my way down, I've got positive x, so there's really a 1 there, positive 1x plus positive 4x. That gives me positive 5x. And now as I get to my last value, I've got a positive 3 and a positive 12, and when I add those together, I get positive 15. And there's my resulting polynomial. So addition, add like terms, don't change the exponents. Subtraction, distribute the negative, then add like terms, don't change the exponents.